Hello students, welcome to Online Maths Classroom. This is an introduction part of your topic statistics, and in this part 1 of this topic we will discuss all the basic concepts and important formulae, right? And the exercises will be discussed in your part 2 and part 3. So let us start with your statistics. Introduction. We know that statistics deals with data collected for specific purposes. We can make decisions about the data by analyzing and interpreting. Okay. In earlier classes, we have studied methods of representing data graphically and in tabular form. This representation reveals certain salient features or characteristics of the data. We have also studied the methods of finding a representative value for the given data. This value is called as the measure of central tendency, right? Recall the mean, arithmetic mean, the median and the mode. These are the three measures of central tendency. A measure of central tendency gives us a rough idea where data points are centered. But in order to make better interpretation from the data, we should also have an idea how the data are scattered or how much they are bunched around a measure of central tendency, right? So let us see what is the meaning of this. Consider the runs scored by two batsmen in the last 10 matches as follows. Say batsman A is having this score and batsman B is having this score. Okay. Now clearly the mean and median of the data are mean for batsman A is 53. You can calculate it by sum of observations divided by the number of observations, and the median by arranging them and then getting even and odd terms. You know the formula. uh, you have studied in your class 10th also, right? So by applying it, you get the median for A is 53 and for B is 53. Recall that we calculate the mean of a data denoted by x bar by dividing the sum of observations by number of observations, right? So if you remember, the formula was your x bar is summation xi divided by n. Okay. Also, the median is obtained by firstly arranging the data in either ascending or descending order and then applying the formula, right? There were two rules. So if you remember them, that if the number of observations are odd, the observations are odd, then the median is your n plus 1 by 2th observation. And if yes, n is even, then the median is your n by 2th and the next n by 2 plus 1th observation, right? And you have to calculate the mean of these two. Okay, right? So we find out the mean and median of the runs scored by both the batsmen A and B are 53. Can we see that performance of two players is same? Does it mean that performance is same? As you see that their scores are different on different matches. So clearly no, right? Because the variability in the scores of batsman A is from 0 to 117. 0 is minimum and 117 is maximum. Whereas the range of runs scored by batsman B is from 46 to 60. So how can you say that their performance is same? So let us now plot the above scores as dots on a number line, right? So this is your number line and these are blue dots are depicting the scores of the scores of the two batsmen, right? And for this is for batsman A and this is for batsman B. Now observe it. Observe it. You can see that here for A the data is more scattered, and see, observe for batsman B. So we can see that dots corresponding to batsman B are close to each other and are clustering around the measure of central tendency, mean and median, while those corresponding to batsman A are scattered or more spread out, right? Thus, the measure of central tendency are not sufficient to give complete information about a given data. Variability is another factor which is required to studied under statistics, like measures of central tendency, right? We want to have a single number to describe variability. This single number is called as measure of dispersion. Okay, we call it as measure of dispersion. Okay, in this chapter we shall learn some of the important measures of dispersion and their methods of calculation for grouped and both ungrouped data. Now, what are measures of dispersion, right? The dispersion or scatter in a data, it is measured on the basis of observation and the types of measure of central tendency used there. And the measures of dispersion are your range, your quartile deviation, your mean deviation, and standard deviation, right? And in this chapter, we shall study all of these measure of your dispersion except the quartile deviation, right? So quartile deviation is not a part of our syllabus, right? So let us start with your range. Range, you know, in the example of runs scored by the two batsmen A and B, we had some idea of variability means in the scores on the basis of minimum and maximum runs in each series, right? So to obtain a single number of, for this we find the difference of maximum and minimum values of each series, right? So this is called as the range of the data. So what is the range? Range is your range of the series is your maximum value minus minimum value, right? For batsman A it was 117 and for batsman B it was 60 minus 46, that is 14. Okay, the range of data gives us a rough idea of variability or scatter, but does not tell about the dispersion of the data from a measure of central tendency. For this purpose, we need to have some other measures of variability. Okay, clearly such measures must depend upon the difference or deviation of the values from the central tendency, and the important measures of dispersion which depends upon the deviation of the observations from central tendency, they are called as your mean deviation and standard deviation. Okay, so this chapter is all about your mean deviation and standard deviation. Now, what is your mean deviation? Let us understand it. Recall that deviation of an observation x from fixed value a is the difference x minus a. Okay. In order to find the dispersion of values of x from central value a, we find the deviations about a, right? An absolute measure of dispersion is the mean of these deviations. To find the mean, we must obtain the sum of deviations, right? But we know that a measure of central tendency lie between the maximum and minimum values of the set of observations. Therefore, sum of deviations will be negative and some will be positive. Okay, the DI table that you frame while calculating your this mean, like DI is xi minus e, you find that some values were positive and some were negative. And if you will obtain, right, you know that in maximum questions it was the middle one where the assumed mean was taken, it is 0, and the upward it was your negative values, and lower it was positive values. Okay, so you find that if the sum is taken, the sum is turned out to be 0. Okay, so mean of deviations is your sum of deviations upon number of deviations, and if they will be 0 by n, it will be 0. Therefore, to find the mean of deviation about mean, it is not of any case for us as far as the measure of dispersion is concerned, right? So what we will do in finding a suitable measure of dispersion, we require the distance of each value from a, okay, or a fixed number e. Recall that absolute value of the difference of two numbers gives the distance between, means we need to ignore the signs. We need to ignore the signs, because if signs are there, like say data like -3, -2, -1, 0, 1, 2, 3. So altogether sum will be 0. So that means I'll not get any idea. So I need to consider the absolute value. Okay, so this is all concerned. This mean is called the mean deviation, the mean of absolute values we need to consider, right? So mean deviation about assumed mean a is your sum of absolute values of deviation from a divided by number of observations. Okay, so see, mean deviation may be obtained from any measure of central tendency. They can be calculated from mean and they can be calculated from median. Okay, so let us see how to calculate my mean deviation for ungrouped data. So firstly, your n observations will be x1, x2, so on, so up to xn. So what will I do? I will calculate the measure of central tendency about which, like if I have to calculate my mean deviation about mean, so I will firstly calculate my mean. Okay, then I'll calculate my deviations. Deviations means I'll calculate xi minus a. Okay, yeah, or x1 minus a, x2 minus a, x3 minus a, xn minus a. Then I'll calculate their absolute values. The same thing that we used to do in di is xi minus a. Okay. So we will consider the absolute values, and then we will find the mean of these absolute values, like summation of these all terms, that is summation xi minus a whole mod divided by n, right? Where, and for mean deviation about mean, x bar is mean, this formula will be xi minus x bar whole mod upon n, where x bar is mean, and for median, in place of x bar there will be m, so it is summation xi minus m whole mod this divided by n. So it is mean deviation about median. Okay, in this chapter we shall use the symbol m to denote median unless stated otherwise, right? So let us take an example quickly. Mean deviation about mean for the data. Say this is the ungrouped data. So what will I do? I'll first find the mean, sum of observation divided by number of observations, which is your 9. Okay, then I'll calculate my deviations. Like, so see, this is deviation means 6 minus 9, like this 6 minus 9, this 7 minus 9, 10 minus 9, all that up to 12 minus 9. So these are C. These are, some are negative, some are positive. So I must take their absolute values. Like I will take it as minus 3 instead of 3. I'll take minus 2 as 2. All are positive. Now their sum is, the sum of all of them is your 22 divided by your 8, which is giving you 2.75. Okay, right? Now mean deviation for group data. So two type of group data are there. One is discrete and other is continuous. Okay, so discrete one data is that in which your x1, x2, so on, so up to xn is given and the frequencies are given, right? Like your discrete distribution is that in which your xi's and f is given, right? And mean deviation about mean. First of all, we find the mean x bar, right, by formula, and then we will apply this formula, summation xi fi upon n. Okay, right? And then I'll calculate my xi minus x bar in the similar way. And mean deviation I have to calculate here because frequency is involved, so I'll use this summation fi times xi minus x bar upon n. Okay, mean deviation about median. So here I'll calculate my median first. Okay, and mean deviation will be like your 1 upon n times summation fi times xi minus m. M is your median, right? So we find the median of the given discrete frequency distribution for this observation are arranged in ascending order. We need to arrange, right? And then we need to find the cumulative frequency, right? Then we will find out my n by 2 and search it in the table of my cumulative frequency, where n is the sum of frequencies. This value of observation lies in the middle of the data. Therefore, it is required median. After finding the median, we will apply this formula to get the answer. And in case of continuous frequency distribution, you will be having your class intervals and your frequencies. Okay, all of them. So mean deviation about mean, how will I calculate? Again, I just go for any methods we can go, right? We can go for our shortcut method for calculating mean deviation about mean, right? So in this case, this is showing your scattering assume mean method. This is step deviation. So like the step deviation method, we used to calculate our di is equal to xi minus a upon h, and the mean was calculated like this, summation fi di upon n into h plus a, right? And mean deviation about median we'll calculate by using the formula. You remember the formula like L plus n by 2 minus CF upon F into H. And then mean deviation can be calculated. Just instead of X bar, I'll use my M. Okay. Then limitations of mean deviation in a series where the degree of variability is very high. Okay. The median is not representative central tendency. Thus, mean deviation about median calculated for such series cannot be fully relied. Okay, in that case, we have to find out for a variance and standard deviation, right? Okay, so another way to overcome this difficulty while arose due to signs of deviations is to take the squares. Okay, so either we can go for taking the modulus absolute values, and the other way is we can take the squares. That way also the negative sign will be removed. Okay, so in this case you will take your, in case of variance, you will take xi minus x bar square, x2 minus x bar square, so on, so up to xn minus x bar square. So it will be summation xi minus x bar whole square. Like as this is an example is given, so you can go for this. If say observations are given, so you can go for your xi minus x bar whole square like this, and you can obtain the sum corresponding, right? And similarly for your observation set of B observations are given here. Again, you can check it out, like, and here as you can see that here in this question, this formula for sequences and series is also applied. N into n plus 1 into 2n plus 1 upon 6, right? So if this your xi minus x bar square is simply our measure of dispersion or scatter about mean, we will tend to say that the set A of 6 observation has lesser dispersion about the mean than the set B of 31 observations, even though the observation in set A are more scattered from mean, okay, and then in the set B, right? So this is the analysis that you can see here. The data is more scattered, and whereas here it is aligned towards the center. Now thus we can see that sum of squares of deviations from mean is not a proper measure of dispersion. Okay, to overcome this difficulty, we take the mean of squares of deviations, right? The average of squares of deviations, right? That is, we take 1 upon n times summation xi minus x bar whole square. In mean deviation we take xi minus x bar mod, okay, and here we take xi minus x bar whole square. Like in set A that we took the example, 1 upon 6 times 1750 will give you 291.67, and for set B it will give the value as 80, right? This indicates that scatter or dispersion is more in set A, right? It is more in set A as compared to scatter or dispersion in set B, right? Which confirms with the geometrical representation of two sets. Therefore, we take your 1 upon n times summation xi minus x bar whole square as a quantity which leads to proper measure of dispersion, right? And this number, that is the mean of square of deviations from mean, is called the variance and is denoted by sigma square. Okay, this is small sigma. Okay, this is small sigma. Therefore, the variance of n observations x1, x2, so on, so up to xn is given by sigma square is 1 upon n times summation xi minus x bar whole square, right? 1 upon n times summation xi minus x bar whole square. And then there is standard deviation. In the calculation of variance, we find that the units of individual observations xi and the unit of mean x bar are different from the variance. Now, since variance involves sum of squares xi minus x bar, right? This squares, sum of squares of xi minus x bar. For this reason, the proper measure of dispersion about the mean of set of observation is expressed as a positive square root of variance. Okay, and this positive square root is called as the standard deviation, right? So standard deviation is nothing but you take the square root of this formula both sides, you'll get it is denoted by sigma, because square root of sigma square is sigma, and towards right we put the square root sign. So standard deviation for continuous frequency distribution is given by this formula, 1 upon n times summation fi times xi minus x bar whole square, right? And divided by 1 upon n, where n is your summation fi. Okay, and the another formula for standard deviation which can be derived by using this result, by opening this result, like I can open it as this whole square as xi square plus x bar square minus 2x bar x by xi, and then by multiplying with fi I'll get this term. Okay, and again from here I'll take out x bar square outside at, as mean is fixed, so it is x bar square summation fi, and again 2x bar from here. Okay, and then it becomes your, this gives you the value of 1 upon n times summation fi xi is x bar, or we say that summation fi xi is your nx bar. So we will replace it by nx bar, right? And it will give me this formula. So this formula can be converted in this way also. So that means your sigma square can be expressed in this way, and in short form we can write like this: 1 upon n times 1 upon n under root n times summation fi xi square minus summation fi xi whole square, right? And a shortcut method for variance and standard deviation is that here we use yi. Yi is xi minus c upon h, right? And mean will be your summation fi xi upon n. And this formula we can use, okay, x bar is equal to a plus h y bar. This is just for understanding purpose, you need not remember it, okay? So the variance of the formula is your 1 upon n times summation fi xi minus x bar whole square, and by opening it and writing it in standard form, we can write this as, okay, so this is the formula which we use. H upon n, h is the height, n is your summation fi root n times summation fi yi square minus summation fi yi whole square, where yi is your xi minus a upon h. And analysis of frequency distribution. Now we have studied that about some types of measure of dispersion has been gone through in this your statistics of this class, right? The mean deviation, the standard deviation, and they have same units in which the data are given. Now whenever we want to compare the variability means the variation with the same mean, okay, which are measured in different units. So we do not merely calculate the measures of dispersion, but we also require such measure which are independent of the units. So for this we choose our coefficient of variation, okay, and this coefficient of variation is having formula CV is sigma upon x bar into 100 when your x bar is not equal to 0, where sigma is the standard deviation and x bar is your mean. Okay, for comparing the variability or dispersion of two series, what we have, we should calculate the coefficient of variation, right? And the series having greater CV will be more variable, okay, than the other, and the series having lesser CV is more consistent or more stable. Now comparison of two frequency distributions with same mean, right? So generally, if say two distributions are there whose x1 bar is the mean of first and sigma 1 is its standard deviation, and for second x2 bar represent the mean and sigma 2 the standard deviation. So we calculate the CV for first distribution by using this formula sigma 1 upon x1 bar into 100. For second we calculate it as sigma 2 upon x2 bar into 100, right? And we use this formula when your mean is same, right? X1 bar equal to x2 bar is can be taken as x bar, right? So here this formula becomes sigma upon x bar into 100 as mean is same, right? So in such cases on the basis of just sigma, because rest of the things are same, so standard deviations will give you the idea of the variability of the data or stability of the data. We say that for two series with equal means, the series with greater standard deviation is called more variable or dispersed from than the other. Also, the series with your less standard deviation will be more consistent than the other. Okay. Now let us recapitulate the formulas, and measures of dispersion are your range, quartile deviation, mean deviation, and variance and standard deviation, right? But we are not talking about quartile deviation in this class plus one. And range is, what is range? It is maximum value minus minimum value. The mean deviation for ungrouped data is taken as about mean, it is taken as summation xi minus x bar upon n, and about median it is taken as summation xi minus m upon n. Remember here neither mod nor square is involved, okay? In case of mean deviation about group data, there one additional thing will be there, that for mean it is summation fi times xi minus x bar upon n, and for median it is summation fi times xi minus m upon n, right? Okay, but here remember that we are going to use the modulus, okay? We are going to use the absolute value, right? Otherwise the result will be 0. So we need to put a sign of mod here, okay? So modulus we are going to utilize, okay? And in case of standard deviation, to make it positive, we consider the squares, okay? Now the variance and standard deviation for ungrouped data. Variance is given by this sigma square is 1 upon n times summation xi minus x bar square, and for standard deviation is the square root of this. Now for your discrete frequency distribution, it will become sigma square means variance is 1 upon n times summation fi xi minus x bar whole square, and standard deviation is square root of this. Now for continuous frequency distribution, the formula for sigma square is 1 upon n times either the same one, okay, 1 upon n summation fi xi minus x bar whole square, or it is 1 upon n times root n times summation fi xi square minus summation fi xi whole square. And this is the shortcut method to find out the variance and standard deviation, right? So which is your sigma square is your h square upon n square times n into summation fi yi square minus summation fi yi whole square, and standard deviation is the square root of all this. Okay, so square root means h upon n will be out of the root and rest will be inside the root, where your yi is xi minus e upon h. A is the assumed mean, and coefficient of variation is your sigma upon x bar into 100, provided x bar is not equal to 0. And for series with equal means, the series with lesser standard deviation is more consistent or less scattered, and vice versa, right? So this was all regarding the introduction part of statistics. So you must remember all the formula well, right? Write the formula again and again, and just decide to use particular formula. Like for some questions, some particular formula are more suitable, so you should be having a suitable choice of formula for doing a particular question, right? So memorization of formula is must, and the calculation part is very important, right? So I think whatever we have done is clear to you. Thank you so much.